Hi, so today we're going to learn about divergence, and this formula here describes the divergence in a vector field. So we'll go through what each symbol means. The first symbol is the del operator, and the del operator will be a vector of derivatives in each one of the base coordinates. So let's say that we're dealing in a 3D coordinate space with x, y, and z base coordinates, then we will have a derivative in each one of those base coordinates. So ddx, ddy, and then ddz. Technically, these derivatives will be a partial derivative, so instead of the d looking like this, it will look like this. The reason is because the vector space at each one of these coordinates, the vector function can be described by a combination of x, y, or z. So the next symbol, f, is a vector function. And then in this case, it's going to be in the 3D coordinate space. So it will have f of x that describes the vectors in the x direction, f of y describes the vectors in the y direction, and f of z. So the last symbol is the dot, and this is the dot product. Okay, so why is it that this combination leads to divergence? So this could be illustrated by if we just write it out. So we'll just take the dot product of the del operator with the vector function, and we'll assume that these are the values that were given. This will be equal to d dx times f of x plus d dy times f of y, and then the same thing will be for z. And the dot product always gives a scalar value instead of a vector value, so this won't have any direction. It will just be a plus or minus magnitude. And I think this idea is best understood if we draw out a coordinate space, so I'll draw that out real quick. So this coordinate space will have just the x and y coordinates. It won't have any z direction, but the intuition will still apply even if there is a z coordinate. So imagine if we have a vector here that points straight upwards with a certain magnitude. And then there is a vector right above it that also points straight upwards, but has a magnitude twice its size. We can conceptually see that as we move upwards, the vector value, the vector magnitude will increase, but the direction won't change. So we know that the slope of the magnitude must be positive. If the derivative of f of y with respect to y is positive, then we know that the magnitude of the vector will increase. And this is the definition of what divergence is. Divergence will just give us how much a vector field increases, whether the vectors will get bigger or smaller. So the opposite would be true if this blue vector was instead a smaller vector as it goes up. If this red vector instead described the vector right above it, then the divergence would be a negative, because as you can see, the red vector is smaller than the white vector. And you could apply this intuition to any direction. So imagine we have a vector here that also points straight upwards, but we want to see the divergence as we move over to the right instead of up. So if we now draw a vector to the right of it that looks like this, and let's say that the y direction will still have the same magnitude as the vector to the left of it, but now there's an increase in the x direction. So we know that we could find this increase in the x direction by just taking the derivative of f of x with respect to x. This just means that as we move over to the right a little bit, this will find the slope of the increase of f of x with respect to x. And if the slope of the magnitude is positive, then we know that as we move over to the right, the vector in the x direction will grow. So before, the left vector didn't have any component in the x direction, but because we move over to the right and the slope was positive, then there will be a vector that grows to the right. That is a general overview of how this equation leads to divergence. I hope that helps. Yeah, thanks for watching.